Hello everyone, welcome to the another lecture of Atomic Structure class 8, myself Suman Singh. So in the last class we have discussed about the valencies, right? So now in the today's class we will discuss why do atoms combine to form molecules, okay? So we know that atom combine to form molecules in order to attain what? Chemical stability, right? Why do atoms combine? Atoms used to combine to form a molecule just to attain the stability, okay? Because they have an incomplete valence shell, okay? Mm, because this atom, why these atoms are combining to form molecules? There are two reasons. First is to attain stability, and the second one is to complete its octet, okay? Or we can say that to completes its valence shell, okay, or outermost shell, right? Now we have discussed about this, right? Outermost shell or valence shell. Now next is element. What did these elements used to do? These elements try to attain the stable electronic configuration of the nearest noble gases, okay, either in the form of octet or in the form of duplet. We have discussed about this, right? Octet and duplet. Now next is either by octet or doublet. So when they will form octet or doublet, at that time either they will gain electron, okay, or lose electron, or they will or there will be a sharing of electron with one another. Means what? Why these atoms are combining, or why these atoms are combining to form molecules? Because what we have got two three reasons, right? First is to attain stability. Next is to come to complete its outermost shell or valence shell, right? So how they will attain its stability, or it will complete its octet, complete its valence shell, either by an octet or by duplet, okay? So how this octet and duplet they will achieve? They will achieve either by gaining electron, or by losing electron, or by sharing of electrons, right? So I hope you have understood this, right? Next is ion formation. Ion is what? When we talk about the ion, always remember that I will give you one example of ions. What is ion? Suppose any atom, neutral atom, suppose this is a sodium, it is a neutral atom, right? Neutral atom of sodium. Let me change the color. Suppose this is a neutral atom of sodium, okay? So what this sodium will do, this is a neutral now. What it will do, if it is giving its one electron, okay, so if it is giving its one electron, it will change into Na plus, okay? So at that time this is called what? This is it means that it has converted into ion, okay? Now next is, suppose this is chlorine and it has gained one electron, and it has converted into Cl minus, okay? So here in this case it is losing an electron and becoming what? Na plus, right? And in this case this is chlorine is gaining an electron, it is becoming Cl minus. So this is also called ions, and this is also called ions, okay? But when an any element, or when an any atom is giving its electron, at that time they will be called as cation, okay? They will be called as cation. And when any atom is gaining an electron, as you can see in the case of chlorine, it is gaining an electron, right? So this is called anion. But both are ions. But if in the case where they are giving an electron, they, at that time they are called cation. When it is gaining an electron, at that time it is called anion, okay? So I hope you have got some idea. Now we will see what is written here. We know that when an atom loses or gain electrons, what will happen? It will develop either positive or negative charge, okay? Because the balance of positive and negative charge become unequal, okay? That is why in this way the ions will form, as I have already told you, right? Now next, what will happen? The ions are what? Ions are charged particle, okay, formed due to the loss or gain of one or more electrons, right? Due to the loss or gain of one or more electron, right? As we noted, ions are what? Ions are charged particle formed due to the loss or gain of one or more electrons by an atom, right? So when they will form positive charge, okay, when they will give an electron. Okay, the positive charge ion are called what? Cation. As I have already told you, at that time what it will do, it will give its electron. Okay, if any neutral atom is giving its electron, at that time it is converting into an ion, and that ion is called what? Cation. Okay, now next, when they will gain an electron, at that time they will develop a negative charge on them, and at that time it is called what? Anion. Okay, as you can see in the case of chlorine or in the case of oxygen. Okay, now next, as you can see, one example is given here. The example which I have given you previously, it is given here, right? So I hope you have understood about the concept of ions, right? Now next is, how do atoms combine? So we know that atoms combine with one another according to their combining capacity, known as valency. Valency, we have discussed about this valency in detail in the previous lecture, right? So valency is what? It is the combining capacity of an atom of an element with an atom of other element to form what? Molecules. Okay, valency is what? It is just a combining capacity of the atom, okay, of an element with the atom of other element to form what? Molecules. Okay, so we will discuss about this in detail now. Now next is, the valency of an element or a radical is the number of hydrogen atom that will combine with or displaces one atom of that element is called what? Radical. Okay, we will discuss about this now. First example is given, valency of hydrogen is 1. How? We know that in a compound of hydrogen chloride, HCl, okay, one atom of chlorine combines with what? One atom of hydrogen. Okay, that is why what we can say, the valency of chlorine is 1, because in HCl one atom is shared by hydrogen and one atom is shared by one electron is shared by hydrogen and one electron is shared by chlorine. That is why in this case the valency of chlorine will be 1. Okay, now next case is hydrogen sulfide, H2s. As you can see, is in the compound of hydrogen sulfide, one atom of sulfur combined with two atoms of hydrogen. Okay, one atom of sulfur, it's combining with two atom of hydrogen. Okay, two atom of hydrogen, right? So at that time what we can say, the valency of sulfur is what? 2. So you are seeing, right? Just valency is what? It's the combining capacity of the atom of an element, right? Now next is H2SO4. So here one sulfur, okay, radical is combining with two atom of hydrogen. Okay, as you can see, two atom of hydrogen, hence what will be the valency of sulfur? It will be 2. Okay, now next, in the last example, HNO3. Okay, here what will happen? Nitric acid or one nitrite combined with what? One atom of hydrogen, so the valency of nitrate is 1. So I hope you have understood this, right? So always remember that it is not fixed that the valency of a particular element will be fixed, okay, or particular atom is fixed. There are some of the elements which have a variable valencies. Okay, we will see what is the which are that elements. Elements like iron, tin, lead, sulfur and phosphorus, they have a variable valency, means their valency will change according to their compounds. Okay, what compound they are forming or what elements or what molecules they are forming, according to that their valency will change. Okay, so you see, if in the first example is given, in case of iron, okay, in case of metal exhibiting a variable valency, we will see, always remember that we represent the lower valency by adding suffix ous, okay, to the name of the metal. To represent the higher valencies, we used ic is attached to the name of the metal. Okay, we will see the example of iron. Iron has two variable valency, one valency is +2 and another one is +3. Okay, so when it is attacking when there is having a valency of +2, at that time we write ferrous, FeRrous. Okay, as you can see, ous, right? And when there will be a valency, higher valency means +3, at that time we used to add ic, you can see ferric, right? So here you see that, always remember that the symbols remain the same but the name changes. Okay, if there is a lower valency we will use OUS, and if there is a higher valency we use IC. Okay, as you can see in the case of ferrous, when it has a +2 valency +2, and when it has a valency +3, at that time it is ferric, right? Now next is, in the modern method we use this Roman number. Okay, this Roman number you used to use. So in the modern method the variable valency of the element is represented by a Roman number. Okay, thus the ferrous ion is represented by, as you can see, this, and ferric ion is represented by this. So what is the advantage of this modern method or modern convention? So the advantage of the modern convention is that neither the name of the element or nor the symbol changes. That is why we are using this modern symbol, right? So now in case of non-metal, when we talk about, this was the case of metal. Now in case of non-metal, example phosphorus has 3 and valency of 3 and 5. Okay, so with chlorine it forms two compound, one is PCl3 and one is PCl5. So what will happen, therefore the phosphorus molecule of phosphorus trichloride, okay, which has a 3 chlorine atom, as you can see, when there is a phosphorus trichloride, at that time there is a 3 chlorine atom in it. Okay, and it has a lower valency of 3, right? Now in the case of PCl5, phosphorus pentachloride, at that time it has 5 chlorine, as you can see, right? And the atom has a higher valency of 5 for the phosphorus atom. So I hope you have understood about the concept of valency. Now last is radical. So what is radical? Radical is also very simple or same as ions. Okay, so we can say that radical is what, is an atom of an element or a group of atoms of different element. Okay, that behave as a single unit. They will behave as a single unit, either in the case, either it will be positive or it will be negative. Okay, now next is some of the positive radical example is given here, Na plus, NH4 positive, etc. Okay, and some of the negatively charged radicals is given here, NO3 negative, Cl negative, etc. Okay, now always remember that the basic radicals are also known as cation and acidic radicals are also known as anion. So this chapter is over here. Okay, so try to I have given you the exercise of this chapter, right? So in the next class we will start the another chapter, which is language of chemistry. Okay, chapter 5. Till that, thank you.